In order to define the 6 trig ratios, first we have to start with the distance formula, which is shown here. It's the distance between any two given points. What we're doing is we're putting an angle in standard position with the vertex at the origin. When we do that, we have then defined x sub 1, y sub 1 as the point 0, 0. So when we use this distance formula, really what ends up happening is we're taking the square root of that x sub 2 squared plus y sub 2 squared. Now rather than calling this d for distance, we're actually going to use r, which is for radius. As we progress into chapter 6, you will see why this is the radius, but if you can envision swinging around this circle, the terminal side of the angle would be the radius of the circle. So we call this r, and really our formula ends up being the radius is equal to the square root of x squared plus y squared. We drop the sub 2 on there because we know that the first point has to be the origin, so all we have to do is identify x and y. This r value is always going to be positive. The reason is because it's a directed distance, but it is an undirected distance, so there is no positive or negative, it's simply a positive value. Once we define r, we can then use that with the trig ratios in order to define each function. Those functions are listed out on your notes and also in your textbook on page 503. They start with the sine of theta is y over r. The y value is this height. The x value is the horizontal distance. As long as the angle is in standard position on the coordinate plane, we can use any point along the terminal side except for the origin to find the 6 trig functions. Remember, origin is always x1, y1. So what they've done is they've shown you a point P defined as some xy value. The distance from O to P is defined as r. They've then shown a distance P prime. That's what that little apostrophe means. Its coordinates are x prime, y prime, and the distance is r prime. So what they've done is they've actually created 2 triangles. The first triangle is triangle OQP, and it's here. The second triangle is OQ prime, P prime, and it's here. Now if you can remember from geometry about similar triangles, angle theta is the same for both triangles, and they both have right angles, which means that these are similar triangles. It forces the third angles here to be the same. They're similar triangles. The significance of this is that regardless of which point P or P prime you use, the sine of angle theta is always going to be the same because they are proportional. So the sine of angle theta is going to equal y over r, or it'll equal y prime over r prime. But because they're proportional, it doesn't really matter which point you choose. My advice is to always choose a point that's going to be easy to work with, so nothing with decimals. We can also find the 6 trig functions of an angle if we know the equation of the line of the terminal side of the angle. Now we know that it isn't really a line that's shown, it's a ray. But we could extend that ray and it would be a line, and if that were the case, This would be the equation of the line, x plus 2y equal to 0. Since it's a ray, we add on this x must be greater than or equal to 0, meaning that this is really for all positive values of x. Now remember, we can choose any point along this terminal side as our xy values. So we should probably pick a point that will be easy to work with based on what we're looking at. I'm going to choose the point 2, -1. So I'll start with letting x equal 2, and I will actually plug that into the equation. So it's 2 plus 2y is equal to 0. And if I solve for y, I have the coordinates -1. Now I have to use these to find my r value. Remember that r is the square root of x squared plus y squared. Remember, it's the value -1 squared, and a negative squared is a positive value. So this is going to be the square root of 5. And I'm going to leave this as the square root of 5 rather than getting a decimal approximation because this is an exact value. So now I've got an x, a y, and an r, and I can do the 6 trig functions. So the sine of theta, we know that that's y over r, -1 over the square root of 5. Cosine, that's 2 over the square root of 5. Tangent, well, that's y over x, so it's -1/2. Cosecant, square root of 5 over -1. Secant, square root of 5 over 2. And cotangent, 2 over -1. Now these values, while they're correct, are not simplified, they're not rational. So a few things that we need to pay attention to. We are not allowed to have radicals in the denominator. But remember that mathematically we can multiply any fraction, the same value in the numerator and denominator, and it will be equivalent because any value over itself is equal to 1. So in the case of these, I will multiply by square root of 5 over square root of 5. What happens is that the numerator becomes negative square root of 5, the denominator becomes 5. I can do the same thing with cosine. Multiply numerator and denominator by the same value. My numerator becomes 2 square root of 5 over 5. Tangent is perfectly fine. This cosecant, we don't usually put negative values in the denominator. We usually bring them up. So this could be negative square root of 5 over 1, but since the denominator is 1, it can simply be negative square root of 5. Secant is fine. Cotangent, we would do the same thing. Negative 2 over 1, or simply -2. When we're working with quadrantal angles, it's easiest to use an r value of 1. You'll see when we get to Unit 6 that this is part of the unit circle. And if you look, for 0-degree angle or 360, the x-coordinate is 1, y is 0, r is 1. If we look at a 90-degree angle, x is 0, y is 1, r is 1. Here's 180 degrees, 270 degrees. We can use these values to get the trig ratios for all 6 on these particular angles. So let's just start with a 90-degree angle. So if we take the sine of a 90-degree angle, remember that sine is y over r, so it's 1 over 1. Cosine is x over r. Tangent is y over x. Big problem. You cannot have 0 in the denominator. The tangent of 90 degrees is undefined. And we usually write that. The cosecant the secant this is undefined. The cotangent is 0. We can do this for every one of these angles, but notice what's happening. We have 1s, 0s, and undefineds. So that's something that we should pay very close attention to when dealing with quadrantal angles. If you look on page 507, there's a very big table that tells you for the major quadrantal angles what the value of sine, cosine, tangent, cotangent, secant, and cosecant are for all of those angles, and you need to be familiar with them. Let's do a few examples. Here we know that the angle is in standard position and it passes through the point 12,5. We need the values of the 6 trig ratios. Some things to pay attention to. 12,5 is in quadrant 1, 12 is the x value, 5 is the y value. First thing we have to do is calculate the value of r. Okay, so now we've got x, y, and r. We can figure out those 6 trig ratios. In this case, we don't have any radicals, we don't have any negative values, and everything simplifies quite nicely. Let's try another one. We have an angle in standard position, and it's passing through the point 8, negative 6. So once again, we always start by finding r first. So in this case, r is equal to 10. Here, I'm just going to start right off the bat. 6 over 10 can be reduced. So this is really negative 3/5. This one's 4/5. This will reduce to -3/4. Here, I'm going to remember to move that negative into my new numerator, so I'm going to make that -5/3. And the same with the negative in this one, make that -4/3. Again, it is always important to remember that you need to reduce your fractions, you need to rationalize your denominators, so no radicals in the denominators, and move all your negative signs into the numerator. For this next one, we don't have the coordinates, but we're given the line that defines the ray and the fact that the x values must be negative. So the first thing I need to do is pick some xy values that will work in this. If I start with x equal to -1, one of the things that I notice is my y value is going to end up being a fraction. So I'm going to pick x as -2, which hopefully will give me a little bit nicer coordinate to work with. So I start by plugging -2 in for x. I could have picked any negative value. I just chose the lowest one. So this gives me -6 minus 2y is 0. -2y is equal to 6. So y has to be -3. So my coordinates are -2, -3. I now need to solve for r. I know this is going to come out as a pretty nasty number, so I'm going to have a radical. So this ends up being 4 plus 9, which is 13. R is the square root of 13. Okay, so in this case I see radical in the denominator. I need to multiply numerator and denominator by the same value. And that will give me -3 square root of 13 over 13. Same problem here. Multiply by the square root of 13 in numerator and denominator. A negative over a negative is positive. This becomes 3/2. Here I remember to make sure that my negative sign stayed in the numerator. Same with the secant, kept my negative in the numerator. That shouldn't be tangent, that should be cotangent. Here we've got a quadrantal angle. So this is one that we should just know the 6 trig function values for this. The sine of 360 is 0. The cosine is 1. Tangent is 0. Cosecant is undefined. I know that this is undefined because the sine is 0. The secant is 1. The cotangent is undefined. Again, I know it's undefined because the tangent is 0. The one that's given here is also actually a quadrantal angle. If the terminal side is through the point 0, -5, this is actually a 270-degree angle. So I actually don't have to calculate an R value and go through all of those other motions. If I recognize that the point 0, -5, 0 on the x-axis, -5 on the y, is a quadrantal angle, then I can simply use the fact that I've remembered this information to get my trig function. So the sine of 270 is -1. The cosine is 0. The tangent, this one's undefined. The cosecant is -1. The secant is undefined. The cotangent is 0.